Really, it just takes like one or two. Example 1. Let's do f of x equal 4 tangent of x plus 1. Okay. We know the plus 1. What kind of a movement does that do? Up, right? Up 1. What is the 4 described as? In the front? Vertical stretch. Okay. So there's your transformations. Okay. And we're going to answer all the questions like we did yesterday, and we added 3 more. Okay, so I'm going to show you how to do those later. So A, amplitude. What is the amplitude for all tangent functions? None. Because they don't have the loops. Okay. B, period. The formula, it's not really a formula, but this is how you find period for tangent. Pi over absolute value of b. So pi over absolute value. What is b for this one? 1. Okay. So we don't, b's right here, right? And if nothing's there, it's a 1. So pi over 1. Okay. Absolute value of 1 is just 1. So pi divided by 1 is just pi. So this one says wide as the original one, right? Because it's not being modified by the b. Okay, C. Phase shift. Did we move left or right? No. So none. Now, in my other period, they start putting none on all of them, but is it possible to move left or right? Absolutely, right? So you can move left or right. You could also always move up or down. In this case, the vertical shift, we went up 1. So instead of being at 0, it's going to start at 1. And finally, the midline equation. Since we don't have, right, those loops, we don't have a midline equation. So automatically, none. Because remember how the sine function is like this, right? The midline equation is that middle part. So this one doesn't have those parts. We good, guys? Everybody else good so far? Okay, here comes the new stuff, okay? So, F. The vertical asymptote. So this is the part I really need you to pay attention to, because everything else was kind of like the same as the last. Okay, so the vertical asymptote, the formula, so to speak, is 2, or pi divided by 2b. Okay, that's where you start. You start with that. So pi over 2 times b. What was b again for this one? 1. So I'm going to put a 1 right there. Okay. 1. So 2 times 1 is just 2. That's where one of the asymptotes is located. Okay? But that's just one of them. So where's all the other ones? They're going to happen at odd multiples of pi over 2. Okay, so this is really 1 pi over 2. So what would be the next odd pi over 2? 3 pi over 2. Okay. What would be the next odd multiple of pi over 2? 5 pi over 2. And 7 pi over 2. And that list goes on forever. Okay, because it's all the odd numbers. And you could go to the right or you could go to the left. So negative pi over 2, negative 3 pi over 2, negative 5 pi. Does that make sense, guys? Yeah? Questions? Okay, remember, visualize, because we're not graphing right now, but visualize this in your head. That means there's a wall, vertical asymptote here, there's a vertical asymptote there, there's a vertical asymptote, and so on and so on. That's what that means. Okay, good? Okay. I forgot to do domain and range with you yesterday, so I'll do domain and range tomorrow with sine and cosine, but let's do it with tangent. So domain, as I showed you at the beginning, that graph just repeats for forever, forever to the left, forever to the right. What do we call that forever? Infinite, or all real numbers. Okay. However, we have those asymptotes. Okay, we have those walls. So how do we say it with math symbols? Yeah, it goes on forever, but you have those walls that you have to jump over. This is how you say it. So all real numbers except x cannot equal those walls because they're undefined. You can't touch them. So the way we could say it is like this. Odd multiples. For this problem, it was multiples of pi over 2. So I'm not going to actually list them out because they're infinite. Right? There's 3 pi over 2, 5 pi over 2, 7 pi over 2. Does that make sense? Yeah. Okay. Range. It's going to go up forever, down forever. It's going to write that asymptote. So all real numbers. Always for tangent. Range will be all real numbers. Any questions, guys? Okay, I want to do, I'm not going to do the whole piece. I just want to do the vertical asymptote, just that part, because that's the new part. Just so let's do a more like funky one, so you can see how it works. Okay, we're just going to do the vertical asymptote and the domain, because I feel like you guys can do everything else. It's fine. So we have a up to, a right one, a vertical stretch, and the one that we're still missing a little bit is the B for some of us, right? Because we're a little rusty. So just think of the B as a A. If it was a A, that'd be a vertical stretch. But if it's a B, it's the complete opposite of that. So what's the complete opposite of a vertical stretch? Horizontal compress. Okay, that's how it's the easiest way to do it. Think of it as A, but it's the opposite. Okay, so I'm going to skip to F. Vertical asymptote. Okay. So my formula says that it has to be pi over 2b. So I do pi over 2 times b. B is 4 for this problem. So 2 times 4 is 8. Didn't we get?
What's the F for?
It's one of these. A, B, C, D, F. It's not even necessary. Huh? Yeah, because I feel like you guys, those are fine. I just want to do the, like, one you might be a little bit iffy. Okay, this means one of the asymptotes will be there. Now, where are the other asymptotes? At odd multiples of pi over 8. So at pi over 8, where's the next one? 3 pi over 8. 5 pi over 8. 7 pi over 8. So on, so on, so on.
You have to write that for after we do the class.
This part? You just need to know that for sure. Because like on a test, here's what a test could be. So like this could be option A. Option B could say odd multiples of pi over 8, but they could try to trick you, I don't know, 2 pi over 8. I don't know, different ways. So you have to know exactly that it's those. Does that make sense? Okay, domain. Domain, okay. all real numbers except odd multiples, not of pi over 2. Pi over 2 was the other one, of pi over 8. Makes sense, guys? That's all there is to it. Okay. Arrange all real numbers for these, always. Any questions? Okay, the practice is super short.